Hey everyone, welcome back to my channel, and today we are solving Leetcode problem number 4, which is going to be median of two sorted array. So this is basically the first part of this question where I'm going to solve this problem brutefully, and also I'm going to make up one more video of this question only where I'm going to solve this problem by an optimal approach. So let's see what the question wanted to tell us is that we have two we have two sorted array, which is going to be nums1 or nums2, and all you need to do is to merge these two sorted array. This is how we're going to do it, and then you have to find the median of this merged array, right? As if for now we are solving this question by brute force approach. So this is what the steps that we are going to follow. So first of all, we're going to merge these two sorted array using pointer approach, and then we're going to find the median by applying some operations. So let's see the first step that we are going to do. So we have this array nums1 or nums2. So what we have to do, we know that we're going to solve this array by using pointer approach. So let's take a pointer. For our first pointer, I'm going to take it p, and our second pointer is going to be r. And now I also wanted to, okay, now let's take it like our second pointer is going to be r, and also I'm going to take an empty list, which is going to be our result. So there I'm going to store the element, our sorted elements. Here I'm going to store it. So right now our P pointer is pointing toward 1 and R pointer is pointing towards 2. So you have to compare these two numbers, and whoever is going to be lesser one, we're going to have to insert inside our result. Right, so right now our 1 is less than 2, so we're going to add 1 inside our result like this, right? And after adding, we know that 1 is already added inside result, so we don't want any more. So for that, we're going to move our p pointer ahead by 1, right? And now let's check again that this 3 or this 2. So we know that this 2 is less than 3, so we're going to add inside our result, which is going to be 2. And after adding, we're going to move our r pointer ahead by 1, and let's do the comparison again. 3 and 4, we know that 4 is okay, 3 is less than 4, right? So in this case, we're gonna have to add 3 inside our result, and we know that 3 is already added, so we don't need any more. So we're gonna move our p pointer ahead by 1, and let's compare it again. 7 or 4. So 4 is actually less than 7, so we're going to add inside our result, which is going to be this, right? And 4 is added inside our result, so we're going to move our r pointer ahead by 1. And now let's check again, 5 or 7. So 5 is less than 7, so we're going to do the same. We're going to add 5 inside our result and move our pointer ahead by 1, which is going to be 6, right? So yes. And now let's do the comparison again. 7 or 6. 6 is less than 7, so we're going to add inside our result, which is going to be 6. Now the moment come that I actually wanted to explain you is that our nums2 array is exhausted. If you're gonna see here, you're gonna see our r pointer is equals to len of result. Okay, and our pointer is already been iterated till the length of result, means this array is exhausted. So now what we have to do if our array is going to be exhausted? Now here I want to explain that if we have, let's suppose in this case we have these two arrays, and out of one array is going to be exhausted. So what you have to do, you have to look toward the next array which is not been exhausted till now. So you're gonna have to check this array. I'm talking about this array is not exhausted, right? So if it is not exhausted, so you have to add these elements without any comparison. You have to add these elements directly inside your result. You don't need to do any more comparison, right? Because we know that our first array is exhausted and we're going to moving our second array, and we don't have to compare the elements anymore, right? So this is what the catching part over here, right? So I am going to explain you again that if we have these two arrays, and out of which one array is going to be exhausted, so we have to look toward our next array which has not been exhausted till now. And what you have to do, we know that these arrays are already been sorted, so you have to directly add those elements one by one inside our result without any comparison. So this is what we have to do. So we know that in this case this array is exhausted, so we have to move toward our next array which is going to be nums1, and we know that this array is not exhausted till now. We have to add the element inside our results without any comparison. Let's suppose if in this array one more element is there, let's suppose if I'm going to add inside this array is 8, 7 or 8 is also there, so we don't have to compare anymore. We have to directly add all the elements inside our results. So right now in this case we have 7, so we don't have to compare this 7. We have to directly add inside our result, which is going to be like this, right? So this is how we're going to merge these array by this two pointer approach, right? So this is what the first step is. And now let's see the next step, which is going to be calculation of median. So what is median is? So first of all, I want to say that median is the mid value, right? Median is the mid value. Okay, so we have two conditions to find median, is that if our len of array is going to be odd, or if our len of array is going to be even. So if our length is going to be odd, so in that case we know that we nothing have to do. We have to find the mid element, which is going to be our median, right? So how we're going to find the mid element if our length is going to be odd? So which is going to be len of result, flow division by 2, right? So this is how we're going to find the median when our length is going to be odd, right? So now let's move to the next condition, which is going to be if our len is going to be even, right? So if our len is going to be even, we know that we have two mid values, which is going to be this, okay, I'm going to take it, which is going to be this or this, right? If our len is going to be even, so we have two mid values, which is going to be our 3 or this 4, right? So how we're going to find the mid value inside this? So we know that the mid value is going to be exist something in between these two numbers, right? So for that, what we're going to do, we're going to take the average of these two values, which is going to be 3 plus 4 divided by flow division by 2, right? So this is how we're going to find the median if our len is going to be even. Right, so this is what the process or the process that we are going to follow in this question, right? So let's see the coding part. Okay, so we know that going to apply pointer approach. So let's take our pointer, which is going to be I pointer or J pointer, and initially both are going to be 0. And now let's store the length of nums1 or nums2 in some variable. So I'm going to take n or m, where I'm going to store the length of these arrays. So len of nums1, and also I'm going to store it inside len of nums2, right? And also we know that we have to take an empty list, where we're going to merge these two array. So I'm going to take an empty list, which is going to be a result, where I'm going to store elements after comparison. And now what we have to do is to just start moving our pointer in these two areas, right? So for that, I'm going to apply a while loop, while I is going to be less than n, and our j is going to be less than m, right? And now what we have to do, we have to compare these elements, right? So let's do this. If nums1 of I, if nums1 of I is going to be less than nums2 of j, right? So in this case, we know that we have to append inside our result the lesser one, the lesser number. So we're going to append result dot append nums1 of I, because nums1 of I is less than nums2 of j, right? So nums1 of I. All right. And after this, we have to move our I pointer one step ahead. I plus equals to 1, right? And now if this condition is not true, so we're going to write an else condition, that let's suppose if our nums2 is less than nums1, so we're going to append nums2 of j inside our result. So let's append it. So result dot append nums2 of j. And after appending nums2 of j, you're gonna have to move your j pointer ahead by 1. J plus equals to 1. Now here what we are doing when our array is not been exhausted. Now what happens if our array is going to be exhausted? So we have to manage those cases also. For that case, let's take an example, or for example, if our length nums2 is going to be exhaust. For example, this array nums2 is going to be exhaust. So what we have to do, we have to move toward nums1 array and directly add those elements inside our results. So what we have to do, because we know that our nums2 array is already been exhausted. So if nums1, if for example nums2 is exhausted, so if I is going to be less than n, so what we have to do, we have to add those elements directly inside our result without any comparison. So while while I is going to be less than n, so we have to add result dot append nums1 of I, right? So this is how we have to do when our nums2 array is going to be exhausted, and also we have to move our I pointer one step ahead. Okay, now if in case our nums1 array is going to be exhausted, so we have to move toward nums2 array, and we're gonna have to directly add those elements inside our result. So let's write the code for nums1. So if our nums1 is going to be exhausted, means nums2 is already, nums2 is exist, right? So while j is going to be less than m, so we're going to apply a while loop while j is less than m. So we're going to add elements result dot append nums2 of j, nums2 of j inside our result, and then we're going to move our pointer one step ahead. So this is how we're going to do the merging of two sorted array and getting the new array. So this is what the sorting part. Now let's write a code for calculating median of our sorted array. So for median we want a length, because on the basis of length we're going to calculate the median, whether the length is odd or even. So I'm going to calculate the length, length, okay, length, which is going to be n plus m, right? So length is basically the length of our calculated array, right, or the merged array, or you can say in this case is result, right, the length of result. Instead of writing n plus m, you can also write len of result, right? Both are same. So now on the basis of length, if our length is going to be odd, right? So let's talk about if our length, length, if our length modulo 2, right? I'm not talking about modulo 2 not equals to 0, means if I'm going to divide this length by 2 and the remainder is not equals to 0, means this length is going to be odd. So in this case we know that we're gonna have to directly return the mid value of our result, right? So we have to return um, mid value, which is going to be result of length length flow division by 2, right? So this is going to be the mid value. And now if in case if our length is going to be even, so let's write inside our else case. So we know that we have two mid values, so let's take it a1, where I'm going to store the first mid value, which is going to be result of length float division by 2, and also we have one more mid value, which is going to be a2, result of length length float division by 2, and let's subtract 1 from it, so that we're gonna get the second mid value. Okay, so I'm gonna subtract 1. So this is what the second mid value, and we know that we're gonna have to calculate the average of these two values. So let's return the average of these two values, which is going to be our median. So let's do this, a1 plus a2 divided by 2.0, because we want to answer in decimal form. So that is why I'm dividing it by 2.0. So this is what the code is, and let's run this. Okay, so nums1 of I, so let's do this, nums1 of I. Okay, here it is accepted, and let's submit this code. And also the time complexity of this algorithm is big O of n plus m, or also the space complexity is going to be n plus m. And we know that this is the brute-full approach, so it is pretty good. And here we have done this question.